So sorry for that. I think I have to solve it again. Sorry for this disturbance. I just forgot to open my mic. I'm really sorry for that. Do not worry, we are on the first question. I will discuss it right now. Okay. So here we are with some questions on work energy and power. So this is our first question. A bullet of 10 gram leaves the barrel of gun with a velocity of 600 meter per second. If the barrel of the gun is 50 centimeter long and the mass of gun is 3 kilogram, then value of impulse supplied to the gun will be. So we know that impulse is nothing but J is equals to change in momentum. This is impulse momentum theorem also. This is equals to the change in momentum. So we are interested in gun. So we need to calculate the change in momentum of gun, which is nothing but final momentum minus initial momentum of gun. So we know that initially the gun is at rest. So you don't need to worry about this initial momentum. Although when bullet leaves the gun, it acquires a recoil velocity in the opposite direction. So we can say that the final momentum will not be zero for gun. How do we calculate it? Because all the forces that is inside the gun, the blast, the jet of gas, okay, these all are the internal forces. So there is no external force applied to the gun. We can say that we can say that the momentum is conserved here, energy is also conserved. So we apply the momentum conservation. So P initial is equals to P final. It is the momentum of system. System we have considered as bullet and gun. So finally, when the bullet leaves the system, its velocity means nothing to us. So we can assume it zero. Initially, it is moving with a velocity of 600 meter per second. So we can say that mass of the gun is 10 into 10 raised to the power minus 3 multiplied by velocity of the gun is 600 meter per second equals to minus mass of the bullet, sorry, gun 3 kg multiply with velocity of the bullet. Now, why I put minus here? Because the bullet will move in the opposite direction to the bullet. Okay. So this will become 200. So finally, VB we have as a value of minus 2 meter per second. So if you are interested in the magnitude only, you can take it. VB is equals to 2 meter per second. So we will take this value. Okay. Now, so now we know the final velocity of the, it is not VB, it is VG, velocity of the gun. Okay. So the momentum imparted here is P final, which is M of gun, velocity of gun, final minus mass of gun, velocity of gun, initial. So it is 0, initial one, and final is 3 into 2, which is equals to 6 Newton second. So this is the answer. Okay. So try to understand what has been asked in the question. So in this question, impulse supplied to the gun is been asked. Okay. If it is interested in the impulse supplied to the bullet, the answer will be different. Okay. Now, in this question, the figure represents the momentum time graph or PT curve, you can say, for a particle moving along an axis under the influence of the force. If the force is applied, the momentum being changed. Identify the region on the graph where the magnitude of the force is maximum and minimum respectively. Now, in this question, a PT curve is given to you. This is a PT curve. Got it? We know that force is nothing but dP by dt, change in momentum per unit change in time. If you will see it carefully, this dP by dt is nothing but the slope of this curve, because if any particular time slab, let's say at t1, if you calculate the value of p, it is this, let's say p1. So this is the line. If you calculate the slope at a, it will be p1 by t1. So the slope of pt curve, slope of pt curve equals to the force applied, or you can say equals to the force. Okay, so now it become very simple. You need to see where the slope is minimum. If the slope is minimum, if the slope is minimum, the force will be minimum. If the slope is maximum, the force imparted will be maximum. So now it is very simple. Just look at the graph. Here you will see this slope has a greater value at region C. Okay. And this value is greater than this value, which means the slope of B is the minimum and slope of C is the maximum. So maximum slope you can see at point C. This line has the maximum slope and this line B has the minimum slope. Option maximum we have C and minimum we have B. Now you can also confuse it because it is option A given B and C and option D is given C and B. So you may confuse here. So try to just read the question once again. It has been asking maximum and minimum. And firstly you have to put for maximum and then you have to put it for minimum. So maximum value के लिए C has a maximum value and B has a minimum. So C and B is the correct option. Okay, option D is the correct option. Now, this question, if you will see, if momentum of a body is increased by 20%, then its kinetic energy increases by. So these types of question are very random and very frequent to ask. Okay, sometime it will change the question like this: if kinetic energy of a body is decreased by somehow percentage, then its momentum will decrease by or increase by. Okay, so these terms can be replaceable, but the concept is same. Okay, so let's try to understand what the concept is. So initially, let's say initial momentum we consider here. Initial momentum equals to P. Okay, so P initial is P. Final momentum, or let's say P final. P final may what has been given in the question, that momentum of a body is increased by 20%. Okay, no problem. So P final momentum plus 20% increase in the initial momentum. So 20 by 100. Okay, it will become 1.2 times of P. Now we know that kinetic energy is given by this formula, P square upon 2m. Now, initial kinetic energy, we can easily crack it. It is P square by 2m. Final kinetic energy will be 1.2 P, the final momentum, square by 2m. Mass is not changing. Equals to 1.2 square will become 1.44 P square upon 2m. This P square by 2m is nothing but the initial kinetic energy. So we can say it 1.44 times kinetic energy initial. Now, the answer is given in the percentage. So we have to calculate the percentage increase or decrease. Okay. So for percentage increase in kinetic energy will be given by kinetic energy final, any quantity, the final minus initial, divided by the initial value, multiply by the 100. Okay. Final momentum you have 1.44 times kinetic energy initial minus kinetic energy initial divided by kinetic energy initial multiply by 100. You can cancel out this kinetic energy initial. You will left with 0.44 multiply by 100. So this percentage change in kinetic energy is 44%. This is the answer of this question. Okay. Let's say if this is a decrease, so what you are going to do? If 20% is decreasing, instead of increase, it is decreasing or decreased by 20%. So what you are going to do? Simple, you just subtract it from the initial value. And then the final momentum will become 0.8. Okay. 0.8 times of P. If you square it, it will become 0.64. P square by 2m, which kinetic energy initial. Now, if you will calculate it, kinetic energy final minus kinetic energy initial. So final you have 0.64. Initial you have kinetic energy initial. So you will take common, so it will be this one minus 36. That this is a decrease, not increase. Okay. In some question, answer will tell you what I am. Am I decreasing or increasing? Got it? Now, this question. So a stone to a, this is a string, not spring. String. So a stone is tied to a string of length capital L, is reeled in a vertical circle with the other end of the spring at the center. At a certain instant of time, the stone is at its lowest position and has a speed u. The magnitude of change in its velocity as it reaches a position where the string is horizontal is square root of x into u square minus gl. Then the value of x is. So we will decode this question according to its sense. Initially, we have taken a, this is a vertical circle. Let us assume this is a vertical circle. Okay. And the length of the string to which the stone is tied is L. Okay. And one of the end of the string is at the center. At a certain instant of time, the stone is at the lowest position. So lowest position is this. Okay. Here, this is the stone. And at this time, it has a velocity u, speed. Lowest position and has a speed of u. So this is the speed. Now the magnitude of change in its velocity, okay, as it reaches to the position where the string becomes horizontal. So here is the position where the string becomes horizontal. Okay. It can also become here. Here also the string is horizontal, but nothing is said about this. So we will assume it for a small. Only the sign will change. So do not worry about that. You can consider it here. So here I will consider the velocity, let's say, is v. But the change of velocity vector is given to us. Let's say delta u or delta v, will say. Delta v vector is given to us. Magnitude of it is given to us as square root of x into u square minus g. So we have to calculate the value of s. Now, if at the lowest position, I will consider my reference line because I'm going to apply the conservation of mechanical energy here. So for the value of potential energy, we must decide the reference line. So I have decided at the bottom. And finally, I am applying the conservation of energy in between this lowest position to the horizontal position. Okay. So this length is L. So this length would also be L. Now, by conservation of by conservation of mechanical energy, so we know that kinetic energy initial plus potential energy initial, kinetic energy final plus potential energy final. Now, initially it is moving with a speed u. Okay, and we know that kinetic energy just depend on the speed. Okay, initial potential energy, because it is at the lowest point and we have assumed the reference line here, so the potential energy will become zero at the reference line. So initial kinetic energy it will have as 1 by 2 times mu square plus 0 equals to final kinetic energy it will have as 1 by 2 mv square plus final potential energy, mass of this, let's say mass we have assumed at m. So mg into height, mgh, we know the potential energy, mgh. But here the h is from the reference line to the final position, it is L. So we'll consider it as mgl. Okay. Now we are calculating the value of v so that we can calculate the change in velocity. Okay. Initially we know that it is moving with u. Finally, we are interested in v. So if you divide this expression by 2 by m, or you can take out this m and cancel it out and multiply the whole expression with 2. So we're left with u square is equals to v square plus 2gl. So from here, v is equals to square root of u square minus 2gl. Okay. Now, change in velocity vector is nothing but final velocity minus initial velocity. Final velocity we have v vector minus initial velocity we have u vector. Now, this is speed given to us. We are converting into the velocity. So we need the direction also. So at the lowest position, the direction of velocity is in horizontal direction. And we know that the direction vector of horizontal direction is I cap. So we can put it here that it is ui cap. Instead of u vector, you can put it as ui cap. And instead of v vector, you can put it at vj cap because it is in vertical direction. And the unit direction vector in vertical direction is g cap. Now, if you try to calculate the magnitude, these two are the perpendicular vector. So we know that if two vectors are perpendicular to each other, the magnitude is given by root of a square plus b square. So here, the magnitude is given by square root of v square plus u square. Now, magnitude we know, we have already calculated. V is equals to square root of u square minus 2gl. Here, the square is given, v square. So this square root will be removed. So now it will become u square minus 2gl plus u square. If you take 2 as common, so it will become u square minus 2gl. This is the same expression which is given in the question. Only the missing thing here is x, or you can say only unknown term here is x, and here we have s2. We can say that x is equals to 2. Okay. So this is the way of dealing that type of question. If you find any kind of question related to the vertical circular motion, any kind of question, you must go through this approach by the conservation of mechanical energy. Simple. Okay. Now, a stone of mass m tied to a string is being reeled in a vertical circle with a uniform speed. Now the tension in the string is. So I have already discussed this concept, but to solve this question, I'm discussing it again here. When this is, let's say, a bob of mass m, so weight mg will acting in downward direction. In opposite to that, tension will act in the upward direction. Okay. You can see here, if any particular value of, let's say this string has rotated at an angle theta, so this angle will be theta. So this component will become mg sine theta, sorry, mg cos of theta, and this component will become mg sine theta. Now we are interested in tension. So tension here is equals to mg cos of theta. I'm equating it, but it is not equating it. In the radial direction, we have acceleration also. So final expression you will have a t minus mg cos of theta is equals to mv square upon the radius of the circle, which is, let's say, r. So from here you can say t is dependent on mg cos of theta plus mv square upon r. Now all the term here is constant. Mass is constant, gravitational acceleration is constant, velocity is uniform, this uniform speed is given, r is also uniform. Only the thing that is changing is theta. So we can say that t is directly proportional to theta here. So as the theta increases, the value of t will decrease, because cos theta, if theta increase, cos theta will decrease. Okay. So we cannot say that tension, so tension here is variable. Tension is variable. Now, if you talk about the topmost point here, here the mass is acting, this tension is developed because of this mass. So mass is acting in the downward direction. And let's say it is a string. It is given in the question. If you try to compress the string, what will happen? Did you feel any kind of resistance in compressing it? No. So it will only resist the extension in length, not the compression. So at the maximum height, this force mg try to compress it or pull it back. So here the chances are that tension can be 0. Okay. So at the minimum, the tension will be minimum at the highest position of the circular path. It can be 0. I'm not saying that it is exactly 0, but it is minimum. So you can say that the minimum at the highest position of the circular path. Okay. Now, an average force of 125 Newton is applied on a machine gun, firing bullet each of mass 10 gram, at the speed of 250 meter per second to keep it in position. The number of bullets fired per second by the machine gun is. Okay. So I will discuss the concept first here. Then I will tell you the simple formula that you can apply to solve these types of questions. Okay. So here we can say that the force is nothing but change in momentum upon change in time. Okay. So if we are able to calculate the change in momentum for 1 second, okay, that is imparted by the bullet. Got it? So we are able to calculate the number of bullets, because if one bullet is imparted a momentum of mv, mass of the bullet, velocity of the bullet, then 100 bullet will impart a momentum of 100 mv. So whatever the change is, we will assume that let it be firing n bullet per second. So in 1 second, the number of bullet fire is n. So momentum change or momentum imparted in the opposite direction of the firing of bullet. Okay, that is why we need a force to hold the machine gun, because as the bullet moves, they impart the momentum, or they apply the force in simple way. They apply the force in opposite direction to the machine gun. Okay, how much force is applied. This is calculated on the basis of change in momentum of the bullet. Initially, they are at rest. When the trigger is pulled down, they are firing with, they are moving with a very high speed. Okay. So we can say that here the momentum imparted, the momentum of the bullets equals to n times. Let's say we have assumed that n number of bullet has been fired, mass of the bullet into velocity of the bullet. And to support that for a 1 second, we need force, because force is nothing but change in momentum upon change in time. So if delta t, let's say 1 second, the force here will become change in momentum. This force is given to you as 125 Newton. So change in momentum will become, because initial momentum is 0. So we can say that n times mass of bullet, velocity of bullet. 125 is equals to n into mass of bullet is 10 into 10 raised to the power minus 3. We have to convert it into kilogram. Velocity of the bullet is given you as 250 meter per second. So if you do the calculation here, n you will have as 50 bullets. Let me just calculate it. N is equals to 1 upon 10 into this 10 raised to the power 3 will become positive going up, multiply with 2. Yeah, it is correct. It will become 50. So 50 bullet, this machine gun is firing per second. Got it? So simple, these types of question mein, you need to apply the formula F is equals to NMV. This. But remember here, the bullet fired here is per second. If it is in per minute, then this scenario will change. You have to convert that thing into per second. Then you apply this formula. Okay. For example, in 1 minute, you will consider, let's say, n bullet has been fired. So in 1 second, how many bullet is been fired? N by 60. Got it? So this modification you have to do in the question. Answer 2 means option 2 is correct. Okay. Now, a particle of mass m moving with velocity v collides with a stationary particle of mass 2m. After collision, they stick together and continue to move together with velocity. So that velocity we have to calculate. Now, this is the question that has been directly says you or indirectly convey to you that this collision is perfectly inelastic collision. I have told you in the previous class. So what has happened in the perfectly inelastic collision? Two bodies come together, make collision, and then they move together as a single body. So that type of collision is termed as perfectly inelastic collision. For perfectly inelastic collision, perfectly inelastic collision, E is equals to 0, and E is nothing but the coefficient of restitution. So E is given by minus of velocity of separation, velocity of approach. Velocity of separation is the relative velocity of the bullet or relative velocity of the particle before the collision, velocity of approach. And velocity of separation is relative velocity of the particle after collision. So if E is 0, then velocity of separation will become 0. which means now they are moving with same velocity, or you can say they are stick together, so they are moving as a single body. Okay, so the relativeness between them is been over. Relative velocity of separation become zero. Now we know that in perfectly inelastic collision, momentum is conserved. Momentum is conserved. Okay, so we can say that P initial is equals to P final. Now, initially, a particle of mass m moving with velocity v collides with a stationary particle, which means that another particle is not moving and has a mass 2m. So we can say that by the formula of momentum, it is mass into velocity. So for this mass particle, mass is small m, velocity is v, plus second particle mass is 2m, velocity is 0 because it is stationary. Finally, they move together. So let's say if they are moving together, their velocity will be same. So you can said that this m plus 2m will be a combined system now. So the mass here we have m plus 2m, and this total mass is moving with a velocity, let's say v dash. Okay. So this will become m into v is equals to 3m into v dash. M and m will cancel out. So v dash will become v by 3. So this is the velocity that they acquired after the collision. Okay. Based on that, the question can be extended to the loss of kinetic energy, because initially the system is, we can say that system is moving with v. After collision, the velocity is decreased by 1 by third. So there will be a loss of kinetic energy. So you can calculate that. Okay. Now, same concept. The repeated frequent question, the frequency of these question is so high previous years. Okay. 100 balls each of mass small m moving with a speed v simultaneously strike a wall normally and reflect back with the same speed. Now, in time t second, got it? The total force exerted by the ball on the wall is, this is the wall we have. Let's see. This is the rigid wall, and these are the balls coming. Okay, and these balls are moving with a speed v. Each ball is moving with a speed v, and the number of these balls are hundreds. They strike the wall and then reflect it back with same speed. They strike it and reflect back with the same speed. So in this process, there is a change in momentum. Change in momentum. Because although they are not losing the magnitude of the velocity, but they are changing the direction. So momentum is mass into velocity. So if velocity is changing, either it is changing by magnitude or direction, the momentum will change. And if the momentum is changing with respect to time, then Newton's second law, the force external or applied is equals to change in momentum per unit change in time. So there must be a force applied to the wall by these balls. So this is a change in momentum. Now we need to calculate this change in momentum. So if one ball, for one ball I'm doing it, one ball, the mass of the ball I can consider small m, which is given to us also, and the speed is v. Okay, so initial momentum is mv, let's say, and final momentum will be m into minus V. Minus come because it is changing the direction. So initially this direction we have considered positive, this direction we would consider negative. Got it? Now change in momentum for one ball is equals to P final minus P initial equals to P final is minus mv, P initial is mv, so it will become minus 2 mv. And if you are interested in the magnitude only, so this will become change in momentum for one ball is mv, sorry, 2 mv. Now how many number of balls we have? We have 100 number of balls. Okay, 100 balls. So for one ball it is 2 mv. For 100 balls it will become 100 into 2m into v. Force is equals to change in momentum per unit change in time. Change in momentum we have 100 into 2 mv. You can say it 200 mv divided by time t second. So this is the force applied by the on the ball. If you take the sign none, so this is the force applied by, because we are calculating the change in momentum of the ball. So this change in momentum is occur because of the ball. So that is why it is minus, because ball is exerting force on the ball in opposite direction. So we have calculated it for the ball. Got it? So it will become 200 mv by t. Option A is the correct option. I hope you got it. Now, this question, we will focus on that. Very good question. As per the given figure, a small ball P slides down the quadrant of a circle and hits the other ball Q of equal mass, which is initially at rest, neglecting effect of friction and assume the collision to be elastic. The velocity of the ball Q after collision will be. So here we have a ball here at P and another ball at Q. So this ball P slide down. As it move down, its potential energy decreasing, converting into kinetic energy, because there is no loss in the friction. It is given in the question, neglecting the effect of friction. So if there is no friction, there is no loss of energy. So this whole uh, potential energy will be converted into its kinetic energy. When it strike this ball, there will be a change in energy during the process. Okay, during the collision. But after the collision and before the collision, we can say the energy is conserved because this collision is elastic. So for elastic collision, momentum is also conserved, energy is also conserved. Now for ball P, firstly we will calculate that how much kinetic energy it has acquired. Okay. Then with the help of that kinetic energy, we are able to calculate the velocity of this ball. And we can apply the momentum conservation so that we can calculate the velocity of this ball Q also. Okay. Now for ball, for ball P. So we are applying the conservation, kinetic energy initial, potential energy initial, kinetic energy final plus potential energy final. So initial kinetic energy is 0 because it is sliding. It is not throw. It has not been thrown. So if sliding means it is starting its motion with 0 velocity. Initial kinetic energy, we will take the reference line here. This is our reference line. So for this reference line, this must be the height and it is nothing but 20 centimeter equals to 20 into 10 raised to the power minus 2 meter. So U will become mgh, the potential kinetic gravitational potential energy. So it will become m into g into h. Mass of the ball, let's say, is m, multiply with g, multiply with 20 into 10 raised to the power minus 2. Final kinetic energy, let's say, half mv square. Final potential will become zero potential energy because now it is on the reference line. M and M will cancel out. Okay. So G has a value of 10. So 10 into 20 multiply with 2 multiply with 10 raised to the minus 2 equals to V square. This power will be cancelled by this. V will become 2 meter per second. Okay. So these balls of equal masses. So initial momentum is equals to the final momentum. Got it? Initially, this ball is moving with a velocity. Now I am here, taking it here. Initially, this ball is moving with 2 meter per second. M into 2 meter per second. This is 2 meter per second. And this collision is elastic. So same mass, same velocity will be imparted to this ball also. Okay. So here the velocity will become 2 meter per second for this ball because the collision is elastic. So in elastic collision, same velocity will be imparted, but after the collision, the direction of the velocity will be different, which means Q is moving in this direction, then V will move in the opposite direction. Because finally we have to conserve the momentum, no? Okay. Option D is the correct option. Got it? Now, in this question, a block of mass small m moving with kinetic energy capital E compresses a spring through a change in 25 centimeter, through a distance of 25 centimeter. When its speed is halved, the value of the spring constant is of used spring will be Ne Newton per meter. So we have to calculate the value of N. Now you can see this block has a kinetic energy E. Okay. When it compresses this spring, let's say it is here now. The spring is being compressed. So spring applies a force in it and it is doing work on the spring. So this work will be stored as the potential energy in the spring. Okay. This change in potential energy of the spring, change in potential, just a second, change in potential energy of the spring, of spring equals to change in kinetic energy of the system. By whatever the change in kinetic energy of this mass block has occurred, the same is imparted to the spring to compress it. So change in the kinetic energy of block of block. So initially the extension or the compression in the spring is zero. Finally, it has been compressed by a length of x, which is given as 25 centimeter. So we can say it is 1 by 2 times k minus 0.25 square. Okay, is equals to, now this kinetic energy, change in kinetic energy, we will calculate as E final minus E initial. So E final, because now the speed is halved at this particular time. So final energy will be 1 by 2 times m V by 2 whole square. And initial will be E, which is 1 by 2 mv square, let's say. So it will become 1 by 2 times mv square upon 4. 1 by 2 mv square is nothing but E by 4. So finally it has E by 4 minus initial. It will become E. Initially it is E. And this is minus of, because we are compressing the spring. So it will become minus 1 by 2 K into 0.25 whole square equals to, this will become 3 by 4 times of E minus. This minus and minus will cancel out. So finally, what do we have? This will become 2. K is equals to 3E upon 2 into 0 point, because 25 is this 0.25, the square of 0.25 will become 0.0625, or more easily you can do it. It is nothing but 25 into 10 raised to the power minus 2. It will become 625, and this 10 raised to the power 4 will come up. If you divide this expression, this will become, this complete thing will become 8 into 3e. So k here is nothing but 24 times e. So the value of n here is 24. Okay, answer is this. So now the session is been over. Thank you so much for being attentive. I hope you got it, and I hope that you enjoy this session. So I will meet you in the next class with more fascinating concept, more interesting questions. Okay. Thank you so much. Bye. Take care.